All right, lesson 9.3, we're going to apply the Pythagorean theorem into a couple different applications. And even in this, after we're done with the video and you're doing the application part, you're probably going to have to come ask some questions. So come see me when those things come up. So I'll throw that out first of all. All right, so in 9.3, there's two main things I want you to be able to do. One is to determine if a triangle is right. And what I mean by that is it a right triangle? Not is it right as in is it correct? And then the second thing is to use the distance formula, and I'll show you the distance formula here when we get there. So, all right, first of all, so we have a possible right triangle. We have a triangle that has side lengths 7, 24, and 25. And we want to know, is this a right triangle or not? Well, the way to determine if any right triangle or any triangle is a right triangle is to take the values and to put them into the Pythagorean theorem, okay, which remember is a squared plus b squared equals c squared. So we're going to take these three values, we're going to substitute them into the formula, and what we're looking for is if the statement, and this is over here is the important part right here, is if the statement ends up being equal, then we have a right triangle. If not equal, then we don't. It's a yes or no type of a thing. Now, remember that the hypotenuse, C, also always has to be the longest of these three sides. Now, in this particular case, I gave you the 25 at the end. Just understand that if this 25 were up here in front, it would still have to go into C. So we're going to put 25 into C because it is the longest. It has to go there. The other two are interchangeable. Now I'm just going to go 7 first and 24 second just because that's the way it's given to me. But you could have flipped them around the other way if you wanted to and went 24 and 7. Okay. So now we're going to go through and we're simply going to do the math. And what we want to see is 7 squared plus 24 squared, is that equal to 25 squared? Okay, which, by the way, 25 squared off the top of my head is 625. I'm going to go ahead and do that. 7 squared is 49. Now, in any of this, if you need a calculator to do any of the math, that's fine. Just make sure you write down your steps. 24 squared is 576. Okay. And again, if I add 576 plus 49 together, that is a total of 625. And so, in this particular case, is 625 equal to 625? Well, the answer to that is yes. So yes, this is, and however you want to answer it, yes, this is a right triangle. Okay? So it does form a right triangle. If those were not equal, then it would not be a right triangle. Okay, let's try this again. So a squared, b squared, and c squared. And again, the 12, oops, sorry, that's a mistake. Not plus, that's equal to. Okay, equal to c squared. And remember, the 12 has to go in for c. Hypotenuse is always the longest. And just for the sake of doing it, I'm going to put 8 into a. I'm going to put 5 into b. And just for the sake of being different. And again, are these equal to one another? Okay, well, 8 times 8 is 64. 5 squared, 5 times 5 is 25. 12 squared is 144. Okay, if I go ahead and add 64 and 25 together, well, that's a 9. 6 and 2 is an 8. Not equal. Okay, so this is not right. So however you want to indicate that those are or are not right. Now this could be a triangle, a 5, 8, 12 triangle. May very definitely be, yeah, it probably is. It should be a triangle. There are other theorems that deal with is it a triangle or not. But in this particular case, even though it is a triangle, it's not a right triangle. So then we're going to get into the distance formula. Okay. We have already discussed so far horizontal distance and vertical distance between 2 points on a coordinate plane. Remember, this is the x and this is the y axes on a coordinate plane. We, in this particular case, though, are going to go through and figure out what is the distance between those 2 points. Okay, and here is the formula that we are going to use to do that. Now in this particular case, you notice I haven't, or there is no points given. So I'm just going to, in this particular case, make them up. Okay, so we're going to call point B, we're going to say has an ordered pair value of 5, 2. Okay, and A, we're going to say, we're going to go the other way. We're going to go to 5. Okay, and what we want to do in this particular case is figure out how far apart these are. Now, the one thing you'll notice, if you look sort of carefully, with our little squares and so on, this is actually an advanced version of the Pythagorean theorem. It's just, it's used on a coordinate plane, and it is actually going to calculate, or help us calculate our legs, and then the final part of it, taking the square root, will calculate our hypotenuse. Because again, we have already done horizontal and vertical distance separately. We're now putting them together. Okay. Now, the other part of this here, and having done some of this before, is to label our points. Now, I go from left to right. So I'm going to let this be my x1 and my y1 over here. Okay, again, now that's supposed to be a comma right there. And I'm going to let this be my x2 and my y2. Okay, so my first x value, my first y value, my second x value, my second y value. Okay, and what we're doing here, first of all, the x2, x1 part, that is actually calculating the length of this leg is what it's doing. Okay, because x determines my right and left. So this, in many cases, we'll call this A. This is doing my A squared part of the Pythagorean theorem. Okay, so if I subtract my x values, which my x2 is a 5, okay, my x1 is a 2, and I've got some absolute values going here because we want to, and I'm going to do this in this, I'm going to finish this part right here. 5 minus 2 is 3. The absolute value of 3 is 3. So what we've just done, and I'm going to stop here before I square it, we have just figured out that this leg is 3 units long. Okay. Now, just for the sake of changing this, the y2 minus y1 is actually calculating this, the length of this leg. Okay, and this would be my b. So we'd go b squared, right? So, alright, so my y2 in this case is a 2, minus my y1 is a 5, and we are going to be taking an absolute value, and I'll talk about y in just a second. 2 minus 5 is negative 3. Now here's why we're going to take the absolute value. If you think about lengths of things, we don't have negative lengths. It's not possible for this leg to be negative 3 units long. So what we do is we just say, you know what, I just want to know how long is it. I'm going to take the absolute value of that. It's 3 units long. Now you notice here, a squared plus b squared would be equal to c squared, okay? And then in the end, you remember the last section, we'd end up taking the square root. Well, that's what this formula is actually going to do for us, because what I haven't written down as we go along here is the square root part, and that square root part will take care of when we took the square root in the end in the previous section. 3 squared is 9. 3 squared is 9. 9 plus 9 is 18. And so now, if I take the square root of 18, the square root of 18 is approximately, and I'm going to just go ahead and do it right here, approximately 4.2 units long. So the distance between A and B is approximately 4.2 units. Alright, so let's do it again. Let us say, I'm going to call this 2, 3. Again, I'm making it up. I'm going to call this 6, 4. All right, and I'm going to change colors here. I'll go to blue. I'm going to let this be my x1, my first x, my first y, my second x, my second y. And so using the formula, my x2 is a 6, my first x is a 2, put those in, those will be squared. My second y value is a 4, my first y value is 3. And absolute value, again, and this is this right here, it would be my leg. That is calculating how long this leg is here, horizontally. The y2 minus y1 would be calculating my second leg. And then in the end, we would be taking the square root of the whole thing to get my length of my hypotenuse. So let's go ahead and just finish the math. 6 minus 2 is 4. That will have an absolute value and square it. I'll do that in a second. 4 minus 3 is 1. That has an absolute value. And I'll square it. And again, in the end, we're taking the square root of everything. The absolute value of 4 is 4. The absolute value of 1 is 1. Those are now both, I can square both of those separately. 4 squared is 16. 1 squared is 1. 16 plus 1 is 17. And so now if I take the square root of 17, which at this particular point, if you want to go ahead and put it in a calculator and do it the quick way, you can. We're talking approximately 4.1 units. So the length between C and D, and this is sort of as the crow flies. If we go direct, it'd be approximately 4.1 units apart. So, all right, you're going to work on some more hypotenuses and applications of the Pythagorean theorem. Obviously, come see me if and when you get stuck on those particular processes. So, good luck.